This presentation provides brief introduction of procedure and nested queries in SQL. This presentation is organized and narrated by Samina Khalid. A procedure is a subprogram or module that performs a particular data manipulation task. Procedures are used when a portion of a code must be repeatedly executed. A subprogram can be called repeatedly within the code, thus reducing the need to repeat the code. Each procedure has a name and may also have parameter list. It also has three parts: declarative, executable, and exceptions. Declarative part is optional. It contains declaration of types, cursors, constants, variables, exceptions, and nested subprograms. The executable part is mandatory and contains statements that perform the designated action. Exception part is optional and it contains the code that handles errors during the runtime. A procedure is created or replaced with create command. In this example, procedure name specifies the name of the procedure. A procedure name must not contain space and should not use any reserved words. In represents the value that will be passed from outside when the procedure is called. Inside the subprogram, an in parameter acts like a constant. Out represents the parameter that will be used to return the value to calling program. An out parameter acts like a variable inside the procedure. An in-out parameter type passes an initial value to a subprogram and returns an updated value. It can be assigned a value in calling program and the value can be updated in the procedure. As keyword is used to create a standalone procedure. Procedure body contains the executable part. This is where the input variables are modified to produce the output variables. End command should be the last line of a procedure. In this example, a procedure is created to calculate likelihood ratio associated with any diagnosis code. This line gives the name of the procedure and type of variables that are used as input in the procedure. The 7-letter long variable called @dx contains the diagnosis code. The procedure will calculate the likelihood ratio associated with this diagnosis code. This section is the execution code. In this section, computer calculates the likelihood ratio for the diagnosis code used to call the procedure. This part of the code reads data from permanent table final in HAP 709 database. For each unique ID, it calculates if the patient has diagnosis or does not. It also calculates if the patient is dead or alive and puts it in a temporary file 1. This part of the code calculates likelihood ratio for patients who have the diagnosis. Calculations are done for situations when no one with the diagnosis is dead, when everyone with the diagnosis is dead, and when some of the patients with the diagnosis are dead and some are alive. This code calls for likelihood ratio procedure. First, the various parameters are declared and calculated, and then diagnosis code is set and the total patient alive and dead are calculated from the data. The execute command tells the computer to run the likelihood ratio procedure and to pass to 3 pieces of data: a constant containing diagnosis code and 2 floating numbers containing the total number of patients dead or alive. This procedure can be called repeatedly and execute to calculate likelihood ratio of different diagnosis codes. This provides an important advantage to coding as it allows portion of the code to be reused. In SQL, it is possible to write a query that contains another query. This type of coding is referred to as nested query. The code is written in few lines of instructions but take the same time to process as the less compact code. A nested query is marked by parentheses before and after the nested code. SQL will execute inner query first before evaluating the code outside the parentheses. Inner query must be able to function by itself. The outer query uses values inside the nested code and cannot function by itself. An example of nested query that first finds the last visit by a patient and then reports the diagnosis during the last visit. In this example, unnested code is written in 2 steps. First step identifies the age of patient at the time of last visit. This data is placed in a temporary file named last visit. Second step identifies patient diagnosis at the time of the last visit. This is accomplished by joining the data table final with temporary table last visit. Nested query puts first step into second step to create one query. The first step used to put the data into a temporary file last visit. The same code shows up here but now inside parentheses and assigned alias A. The same file is also repeated with alias B and joined to itself. The computer will execute the code within the parentheses first. This will make the fields age at diagnosis available for the outer code to use. The outer code uses data from alias A to indicate patient's last visit and data from alias B to indicate patient's diagnosis at the time of last visit. Computation time without nested query was 15 seconds. With nested query, code was compact and it took 23 seconds to execute the query. The reality is that nested queries are not computationally more efficient. Some analysts use it to accomplish the various data manipulation steps with fewer lines of code. Nested queries can make the code shorter and more compact, but do not make the code faster. In massive data, it is not recommended to use nested queries.